Alright, welcome back to another episode of BIM 2K. It's a late night session again, and in this session we're going to be talking about quite an important topic I felt back in the days. At one point in my career I had to do a bunch of estimation, and the estimation part is very fun. Especially with BIM, because you can circumvent a lot of things, you can bypass a lot of obstacles, and obviously you can automate a lot of these components. That being said, one of the big ones was formwork. And formwork is one of those niche specialties, I guess. There's not going to be a lot of companies that are going to be able to do it for, commercial projects. But regardless, you want to have some sort of system to validate some of these things. And obviously, we're at the mercy of the subcontractors usually. And implying this that so we have to kind of provide them with the plans, with some insight, and then kind of hope for the best down the line to get the proper pricing and to get the proper quantities. For most part, it really works out okay, but the problem is we have to still find, we still have to get to the quantities, because in the initial aspect of the estimation process, we have a much more vague estimation process, because we're still not at the stage where we're 100% ready with the plans. We're still not comfortable with sharing the plans with the subcontractors because they're not ready yet, they're not final yet. But at the same time, we want to evaluate the design. We want to see approximately how much it's going to cost. So obviously we have to go through the process, and let's say we're bidding for a project. Well, if we're bidding for a project, then chances are the subcontractors are not going to be involved at this stage. So we have to provide some sense of pricing, and we have to get some, historical statistical data on the estimation part. This implies that it's going to be most likely, we're going to base our price per square footage based on our historical data, and that's going to provide us with some sense of how much this is going to cost us per square footage. Once again, it's a debatable science, but nevertheless, we still go through the process, and obviously we have to do it manually most of the time. So you're going to take a PDF file, you're going to take an AutoCAD file, and you're going to scale things left and right. You're going to measure the the perimeters of the objects, and then you're going to multiply times the height to get the square footage of the surfaces that are in question, because obviously formwork has to go all around. So for example, this object, well, we have to form around some of these components, and we actually don't form up nor down, right? That being said, there are some rules, like for example in this slab we're going to do it from the bottom, we're going to do it from the sides, we're going to do it from the sides, and things like that. Obviously, if this is a slab on grade, it would be under the sides only. So there is a couple of things. That being said, I'm going to use this nice little model. I'm going to assume there's a slab on grade. So I'm just going to change this name to slab on grade. I'll call it like this. It doesn't matter in this case. 250 millimeters. It's a very big slab. Let's just assume so. So the idea is, I've changed the name for all of them. So I don't want to necessarily change for all of them. I'm going to call this slab on grade 250 millimeter. So once again, I only want to change it for the first one. So once again, we have all this data available to us, and obviously we can do the areas, and we can do somewhat certain things we can get to. And the last thing that we will need to do in this process would be to create an Excel sheet to go all this aspect of doing all this. And obviously there is a lot of issues there. Once again, it's not very practical. It's time consuming. When you're bidding for projects, obviously you're going to bid multiple projects each month. So this is a recurring problem each time. That being said, at one point I kind of put an end to it, and I said, you know what, there's got to be a better way. So this is what we're going to do today. In today's session, we're going to try to automate some of this formwork quantity takeoff as much as possible. This implies that we do have to have certain components like this. I mean, even if they're spanning across the building, we would still be able to get somewhat accurate data. But I prefer to have everything right, and obviously this is going to be of utmost importance. And my small rules for any type of modeling gig is we have to do it with the proper ways. So obviously there are good practices out there, and a lot of people are not following them, unfortunately. But rest assured, with my other videos like splitting the columns by level, we are able to kind of bypass some of these limitations and fix some of these issues. So once again, let's just go through the notion of what we need to do. That being said, let's go into our Dynamo. I'll try to explain this, and like I said, if you don't have a model, just create one yourself. At one point, you're gonna run through a model. So obviously, just try to do it at one point and try it out and see what it gives to you. This is customizable, it's going to be expandable. This is the draft version of the final script. So I am providing you with the concept and not the full solution. The full solution is a lot more extensive, but it should be on the way there at one point. The idea is I can't necessarily record a 6-hour session, so I'm going to try to do this to the best of my knowledge without necessarily overtaking too much time. So once again, we have structural columns and we have floors. So what I'm going to do is I'm going to separate this task into two. Obviously, I'm going to select all elements of categories, for example. And in this case, we have a category. Let's just call it structural column. Structural columns. Where are the structural columns? For some reason, it didn't work. So if I run this, you're going to get a full list of a lot of columns, which is exactly what we want. We have 360 columns. It's a lot of columns. So this would have been something, just getting these quantities is a great automated aspect of quantification. Otherwise, in a PDF world, we would have to quantify each one of them individually, even worse. And they might not be the same height, so even more worse. So obviously, nothing, no good news there. But rest assured, we're going to be able to bypass some of these things. So we have the elements. So the best thing that we can do here is potentially we can go into the elements, and we're going to go within the elements, and let's get the geometry out of these things. So usually getting the geometries, we will be getting surfaces, solids, which is okay. So there's going to be multiple ways that we can do this. We could potentially explode this surface, this solid. For example, if I go into my geometry and I go into solid, I could potentially explode these if I have it here somewhere. I used to think that there was, but I don't see it. All right, so it's not here. So is it a modifier, geometry, explode? So we can see here separates come out of a non-separated element into their component parts. So if I do this and I go split, we might get a lot of surfaces, and this is exactly what we need. The only difference is I'm going to just flatten my list at one point. I think it would make a lot of sense to flatten this and then explode it, just because we're going to get less, granularity. We don't get a list of a list. And obviously this is okay. We get a lot of surfaces. So at this stage, when I run this, do I get anything in the back? I get all of these surfaces. Now my main problem is we have these bottom surfaces, we have these top surfaces. So this is something that we want to exclude out of the final equation. We can see all of these, which is great. We could get the area of these surfaces. Once again, it's great. It's just we don't necessarily have this set up the way that we want to. So let's just go through this aspect of doing this. Obviously, we want to be able to look at some of these surfaces. So that being said, we're going to create some centroid point. If I go into my surfaces and I go into my surface, I might be able to get a pointed parameter. And this is usually the one that I'm going to use. So this is a special one. If I ever hover above it, it's going to tell you returns the point at a specified U and V parameter. The U and V, I mean, you have to kind of get used to it. So basically, you're just telling it the geometry, what you're looking at. If you put 0, 0, and I click on it, it's usually going to use an edge, which is, you know, the edge of all the things. However, if I input this 0.5, usually it's going to find the center of both vertical and horizontal component. So obviously, based on this, you can kind of see that we have our center point of all these things, which is exactly what we're looking for. The reason why I'm looking for this is because I'm going to do something later on. With these points, potentially now, I can create a normal vector. So that being said, we're going to create normal points. So once again, I get these points. So if I go and I want to create an abstract, I believe, and I'm going to create a plane if I'm correct. Returns the normal direction of the plane. And let's see, I could create a plane potentially. What would be this called in this case? You know what? Let's create a surface thing. Maybe it's in a surface. So normal at point returns the surface normal at the input point on the surface. So there we go. So I want to get the normal, which is a vector type of thing at the point that I've just created of my surface. So I have a bunch of items and I have a bunch of surfaces, which is exactly what I need because they're the same amount. I can go here for points and I can go here for my surfaces. And if I click on it, I should be able to get a lot of vectors. So once again, what this is providing me, it's the vector usually has a direction. So it's going to be a 0, 0, 1, meaning that it's an arrow. It's pointing in the direction that it's going into. So this is a good way to establish what we need. So once again, we're going to be able to get exactly some of these things. So this being said, let's just go and what do we want to do with this basically? So in this case, if I have a -1 or I have a -1 or +1 here in the x-axis, that means my arrow is going in the x-axis. Simultaneously, if I have this going in the y direction, that means my arrow is going in the y direction. And finally, the vertical direction is going to be my z. So if any of these values are plus or -1 in the z direction, that means that it's in regards to my face that's sitting horizontally, so it's flat onto the ground. So these are the one that we want to exclude because obviously I don't need to form the top side. I don't also need to form the bottom side. On the floor side, it's going to be a much different thing. So that being said, all I need to do now is I need to kind of say, let's create a vector. So what I want to do is I want to compare this. So I have these vectors and I want to basically see if they compare to my x vector. So that being said, potentially I'm going to create an abstract and I'm going to create a z-axis vector. So there we go. I have the vector z-axis and it's basically just a vertical vector. This is 0, 0, 1. So once again, we have 0, 0, 1 in some places, we have 0, 0, 1. It's not the same, but what this tells me that we can potentially determine whatever these two vectors are parallel. So once again, it provides me with this and potentially this, and I can double check if this is going to be parallel. So even if it's going in the negative direction, it's still going to be parallel to this one. So if I run this, you're going to see a bunch of trues, a bunch of false, and basically we should be able to get 4 falses and 2 trues. So once again, what this tells me is that we're going to be able to filter some of these results out. So once again, if I go into my filter, my Boolean, and hopefully this is going to provide you. This is going to be my mask. And obviously what I want to get is I want to get my geometries, and I just want to be able to see true or false if I'm going to be able to get. So once again, this is the flattened list. So once again, we can kind of see that we have in, so these are the trues, there's 2 per object, and then the false, there's 4 per object. So my out series is the components that I want to consider. So once again, this is great news just because we can now get to the bottom of what we want. In this case, I still have both of them. If I ever do watch 3D and I plug in some of these components, am I able to get to them? It would be really nice if I could. And not. Sometimes it doesn't want to show in. Other times it does. So to fit, they're not showing in my watch 3D. It is what it is. I'm just going to have to create something else. So obviously I get these results. I know they're the correct ones. Once I get to other things, I might be able to see them properly. But for now, I just want to be able to kind of select these and extract them. So if I go into my surface and I go again into my surfaces, I'm going to get an area. So I can return the total surface area. So once again, if I take these out surfaces and I run, you're going to get a bunch of results. So I get a bunch of results, and obviously this is not ideal because I have these big numbers. So once again, we can kind of do this one way or the other. Within units, I can convert. Let me just see, how can I convert? So how can I get a unit? So what I want to do is I want to convert potentially this. So once again, I'm just going to convert this. I know I'm working with one thing, and just obviously it's not the greatest thing. I am not working with lengths, I'm working with areas. And these are obviously square millimeters because my project is in metric. If I go into my project units, you'll see that I'm working in millimeters. That being said, most likely my area, we can kind of see here it's in meter cube, but ultimately what I'm getting is not the meter cube. Reason why is because I'm extracting these and the unit type is in millimeter. So what I'm getting ultimately here are square millimeters, and I need to convert this into square feet. And obviously once I do this, this is starting to make a lot more sense. So a singular column, let's assume that this is going to be 10 to 12 feet, and we have approximately 2 feet. These are 600 millimeter. So, if you're looking at 10, we can see that there's 40 to 50, 60 square feet per column. So this makes a lot more sense. Once again, you could convert this into a Python, and it's going to be able to take project units, and potentially we do have it. And I just want to see, do we have project units? So most likely I would be able to extract that through a parameter. I'll find out how to do this a little bit more dynamically without creating a custom node. Like I said, I believe in just creating normal ones and not necessarily custom nodes. Custom nodes are just a little bit harder for people to digest, so this is not the point and not the obvious not the obvious intent I meant to say. So lastly, what we want to do potentially is we want to sum this. So I want to sum this. Can I sum? Sure, I can sum these values. And once again, once I run this, you're going to be able to see that I get a bunch of them. Potentially, I want to use levels. I'm going to go to my level 1. I want to be able to sum all of them. Am I able to do something like this instead? Not even. Let us flatten this. Maybe if I flatten these results, I should be able to get the proper values. So like I said, I like going through this notion of things just because it provides me with a much more efficient method. I'm able to validate certain things. I'm able to see certain things. So we have all these faces and we can kind of see that this is providing me with 42,547 square feet. Seems like a lot, but obviously it adds up. We have 600 by 600 columns, we have 300 some of them, so it adds up easily. So once again, we can kind of see how many square footage we have per column, and obviously adding all of these up, having all these results provides us with this final value of this much. Always look for odd numbers, but obviously we don't have an odd number, so this would be the final list. So okay, we have this. So what I like to do is I'm gonna potentially separate these. These are my selection. I'm gonna call this structural columns selection. And I'm gonna select everything else and I'm gonna group this and I'm gonna call this group execution. I'm going to add some more details later on, obviously. If I select all of them, I can clean this up a little bit. So once again, I get all these odd results. And you can see quickly how fast I got to these numbers. Something like this would take me a lot of hours to do manually. Once again, you have to ensure, you have to make sure of this, you have to make sure of that. There's so many little details. And now what I can do is, I can select this group and I can copy paste it. Why I like to do this is because later on I can just copy paste this as well, and I can change these for floors. And obviously my floors will change a little bit because now I need to look at the bottom side. I can't look at the top side, so I'm going to have to remove one, and I also have to look at not only my z-axis, I need to look at my other one, my x-axis. Once again, I get a little bit more aspects. So what I want to do is I'm just going to deselect this and I'm going to run this. The reason why I'm running this is I want to see the name potentially of the selection. So I want to be able to see what type of element I'm working with. So it's going to be a little bit different because I have to go to these elements. Remember, I have two sets of elements. I have one for my regular floors and I have another one for my slab on grade. My slab on grade will only have the side panels. My top one will have side panels, side formwork, and it's going to have also the boards on the bottom or whatever you want to call it. So obviously there is a little bit more complexity. So once again, we're going to try to separate this in two, and the best way to do this is I want to get the name of this, and potentially I'm going to be able to get this name. So let's just go with this element and I'm going to get the name of this element. I want to be able to see what type of element. Once again, and here it's great. I see that all of them are something except one. And obviously in a typical project you would have more than one component. I want to be able to do this systematically, and potentially I can look at the concrete versus, different steel. In this case, it's all concrete, but obviously the same technique would apply. So I'll reuse this for later. Actually, I'm going to reuse this for now. And within this element name, I need to look for string, and I want to be able to find if there is a string. Potentially, I'm just going to go into strings. It's going to be a lot easier. So within here, I'm not going into, keep forgetting where strings. Strings, all right. It's late at night, so obviously it's a little bit different. And I just want to look if it contains. So if it contains, I'm going to just put in quotation mark, slab. You can ignore the case by default is on, but I'm just going to create this as true. I want to ignore the case. I want to be able to search lowercase. You know, you never know within a project you're going to have. But usually, yeah. Actually, grade. Slab is not the correct one. I want to look for grade. And I'm just going to put this as an example. I'm going to put a capital G. So obviously, if I go like this, it should provide me with all false except one true. So once again, this is just providing me with a little bit more to play with. I'm going to hide this a little bit lower. I want to be able to see it, but I want to still concentrate. So all I'm doing here is I'm going to do a filter by Boolean mask. And obviously my Boolean mask is this, and the category elements is this. So obviously I get one there, I get another there. In this case, my in is my trues. So obviously this bottom one only needs to have the side one. So this would be applicable because I'm extracting entirely some of these things. I don't need the top nor bottom. It would apply to it. So if I go here, just ensure that I'm changing to the correct one. Very unfortunate I have to do this manually. There is better ways to do this. Not a lot of work once you set it up. You just kind of have to change your input. If I run this, I should be able to get to a value. So now you can see I've added this floor. But we're only getting that side value, 250. We're talking about a foot. So you're using a parameter, which makes sense that it's giving approximately this. So there is 470 approximately, maybe 500 feet of parameter, which is a big building in this case, which makes sense entirely. So now I have this. What I want to do is I'm going to copy this again. The reason why I'm copying this is because now I'm using the out elements. However, my out elements, I do need to filter some of these things out. However, I still need to get my out ones. So here, once I get my in ones, because I am not, I'm going to just drop one of them. It might not be 100% because I still have the columns, but obviously what we estimate, we want to estimate to the best of our knowledge. There are going to be some small discrepancies. There's always going to be a little bit more. There's always going to be a little bit less. I mean, ultimately we can fix this in certain ways, but for now we're just going to focus on doing it the simple way and the long, and you know, you can kind of tailor this better later on. But all I want to do is potentially I'm going to get these, and obviously I'm going to drop the first value because I have two values that should be the equivalent. So basically I'm just copying. I'm going to copy these components, and I'm going to have one for ins. However, I'm going to do rest. It's a node called rest of results of items. So I'm just going to remove the first one because there's two of them, right? So if I run this, it should give me these values. Obviously I have two items. I still have one item. Potentially I should flatten this list. Ultimately, which is not flattened. So my out list is this one. It's not giving me the correct. So I get on my out list. Should I be able to get more? Just a second. Let me just drop these. And you can kind of see what's happening on the screen there. There's a lot more values. So this is, you know, a good sign that we're progressing towards where we need. And we can kind of see the power of BIM. BIM has a lot of values. So obviously when I select here, I get two surfaces, which is not what I'm looking for. My in values, the main issue I have here, most likely I just need to flatten this one more time. Let's see, is it giving me a list of a list of a list? It should be okay for most parts, so potentially I just need to tell what to structure. The idea is it needs to give me only one surface. There we go. So obviously it was just a list of the list. And if I go into my items, I should be able to see that selection, which is not usually when I select it like this. Surface area. Once again, I get these the wrong thing. I need to do area, and it's going to be square millimeters every time. Square millimeters. And I'm going to run this code. And once again, we can kind of see we have a little bit more. We have 5,000 square feet for the main one, 400 something, but then we get both of these surfaces, which is the side surfaces. We have a lot more floors, and we get all of these components. So there is a lot of things down the line. Ultimately, we just need to be able to get to some of these things. Like I said, I like to see some of these things. If I go watch 3D, am I able to plug in here? I can't even see it. Not even. It's not updating. Luckily for me, what can we do? Potentially because I need to flatten this. The idea is I just want to be able to see that I have one set of items. I do have them, but I'd like to visualize it, and obviously, just for the sake of this argument, not even. Yeah, I give up. Either way, that's gonna be it. I mean, I can create some solids. I could create something else that would validate, but we can see more or less of this code. It didn't take a long time to create this, but obviously we can kind of see the benefit. And once again, I can just add these components to my group, and I'm gonna call this floor selection. So once again, if I select everything, I'm going to just clean my node layout. And now we can kind of see that it's not collapsed, but if I collapse them all, it's going to look a little bit better because obviously it's a little bit more complex. But obviously the whole idea is we can get to some of these results pretty quickly. And this is the ultimate goal, and it's because once you create this, you can reapply this all across the board. I get all these areas. And obviously we see here with the floors, it's a little bit different. We have multiple floors. All I have to do is, once again, I want to sum these results. I could get a list. And I'll create a list, and I'll create 3 items. One here, one there, one here. So if I add this up, I'm going to get this list, and I'm going to get my final value. So once again, we can kind of see that it's providing me with all these numbers. So for the formwork on the floor, we had 238,000 square feet. Everything's adding up. That's the whole intent of this story, is that we want to add up all these components. They're starting to make a lot of sense. So obviously, we just go one by one, and we're trying to reduce them. Let me just make this nice little diagram. And like I said, it wasn't too difficult. All we had to do was think about the problem a little bit. You know, once you have a proper strategy, a proper plan of action, it's not as difficult as it looks. We have to find a proper path forward. So once again, I'm going to explain a little bit what we're trying to do here. I'll re-explain it just so that it provides everybody some type of context. And I am a OCD type of guy, so you'll see sometimes I'm doing all these crazy things and I'm never, I can't stop myself, unfortunately. Just my reality. Just ultimately, I'm trying to create all this. You know, I'm not saving this script neither because I already have it completed, a lot more extensive, but I'm trying to create these from basic, from scratch. And the reason why I like to create these from scratch is because it's providing you with the value that, let's go through the problem individually. Let's simulate what I would go through in real life if I had to create a problem like this. And, sometimes it's in the memory lane far back. So I have to rethink a little bit of what I've used back then. I know how to fix this problem. It's just sometimes it's a little bit vague what I've done. Either way, there's always a way to fix all of these things. So that being said, let me just re-explain this issue. So we select a component, a category of components. We're going to select all of the elements. We're going to explode the geometries. We get solids. We flatten this list and we're going to explode these solids and we're going to get a bunch of surfaces because a solid is composed of multiple surfaces. We get the pointed parameter. We're using 0.5s to get the middle. So both middle of the vertical and horizontal. So basically we get the centroid of a surface. This is going to provide us with a point. So we're going to create on the surface, we're going to get the normal at a point. We have these points, which is great. So obviously we'll get a vector, which is going to be our normal. The normal is usually the perpendicular, vector of a surface, usually a flat surface. If you get a very vague surface, obviously the normal is going to be perpendicular to that point in relation to the curvature, let's say. So once again, it's always perpendicular, but it's a lot more complex when it's a little bit of a dynamic object. Lastly, we're going to look at the z-axis. Is it parallel to it? Obviously, if we have something that's vertical, even if we have a z-axis anywhere else, it's going to be parallel. Going downwards or upwards, it doesn't matter. We get a bunch of trues or false. This way we can kind of filter our components, our surfaces, and we can get the proper ones to kind of just look at the area, convert the units, and then flatten that list and sum these results up to get a proper number. Obviously, to scale this into other categories, we're just copying and pasting, and we're modifying some of these components. For the floor specifically, we have two types of floors. We have one that's slab on grade, so they're sitting on the ground. Not much to do there, you're just doing the side formwork. But obviously for everything else, you kind of have to create that form underneath it. It's a structural slab, so obviously there is a little bit more complexity. Once again, we get two sets of elements, one that goes up and then one that goes down. And basically the group execution is getting formed. The only difference is for the top ones, we have to exclude one of the top items because one of the surfaces that's flat. Because we're only forming at the bottom, I am excluding one item out of each list, which only gives me one surface per object. And obviously the out result, the side ones, I'm considering all of them. So I get a little bit of everything, and once I've combined this, I'll get to the proper numbers. So we can see that we got to these numbers real quick. Down the line, I do, the rest of the script. And the rest of the script would be for me to export these values in an Excel sheet. So I would get all of these reports down the line. And it's very efficient. I can get to everything that I want. And this provides me with a quick way of evaluating certain things without necessarily overburdening myself. I've used this tool and this script for validating quotes because usually we get multiple quotes. They have a lot of variance between them. So now we're not too sure who's right, who missed the ball, who's not, accurate 100%. So there's always that issue. So obviously when we get into that situation, I want to be asking the subcontractors for the quantities they've used to get to this quote. This is my best way of validating some of these estimates. If you get a proper quantities that they use, the square footage of each type of category of objects, because obviously forming a slab is a lot different than forming a column. There's different costs associated. I can quickly just see if they're in 100% not accurate or accurate. If it's close to the value that I have, obviously I'm going to say, well, you know what? The columns are not giving me 100% of the accuracy. I'm not getting the proper results. I might have, some ups and downs. Obviously we have buffers because I'm not taking away, I'm not giving it away. I should be fine. And usually I'm able to get up to 90% accuracy with this type of method. But 90% accuracy is very good for certain things. And I'm just using a round number, obviously. But if you're going to be able to get up to that accuracy, then it's a good validation tool. If somebody, is their variance is maybe 30% of the value that you have, well, this is a good indicator that potentially they've done something wrong. So you want to go through with these subcontractors and evaluate a little bit of their processes and how did they get to these numbers. Usually there's a logical reason to why, and it could be potentially they're at fault, it could be potentially that I'm at fault. But either way, it's good to double check. Obviously, the subcontractors, they do appreciate this. The last thing that we want to do is get, in the middle of a project and then realize somebody's off on the quantities. Now, who's to blame, who's not to blame? And then it's a blaming game, and then it's who's paying for the extras. It's a whole aspect of change control, change management. We don't want to get into these things. We want to avoid this at all cost. So that being said, this is that final product, and we can see we get all these results. This is all that we've taken in consideration. So we can see there's a lot of quantities, obviously, relatively quick. We get all of these in a short period of time. And now that my script is done, I can just copy paste this all across the board. It provides me with a very effective method at getting something quick. So once again, thank you for sticking around and subscribe for more. I'll see everybody in the next episode. And like I said, I'll continue through these episodes once at a time. Eventually, I'm going to go deeper into these subjects. It's just I can't create these 6-hour sessions. I don't think anybody's going to be focusing on a 6-hour session. I've done it in the past, and it's, I think it's overwhelming for both me and the readers and the audience. So we'll just avoid that type of scenario. I'll break it into more manageable videos. Thank you again, and I'll see everybody next time.